Hi there, and welcome back to CeADAR AI Digital Twin Lighthouse project. In this video, I want to take you through the structure and life cycle of AIDT. Think of digital twin like a virtual clone of physical object or system. It is a software model that allows us to simulate and test various scenarios. But in order for this virtual clone to be effective, we need to make sure this structure accurately presents the physical object or system it's modeling. And that is where the life cycle comes in. Just like any physical object or system, a digital twin has a life cycle that spans from design to dismissal. This is important to carefully manage this life cycle to ensure that digital twin remains effective and up-to-date throughout its lifespan. So in this video, we are going to explore the different types of digital twin frameworks, as well as the life cycle of digital twin from design to dismissal. By the end of the video, you will have a better understanding of how the structure and life cycle of digital twin are crucial for this successful implementation. AI digital twin is advancing at a rapid pace and is being applied to a wide range of industries. However, not all AI digital twin frameworks are created equally. In this section, we will explore 4 types of AIDT frameworks that have been proposed in recent years. The first type of AIDT framework is the 3-dimensional DT, which was first introduced by Michael in his product lifecycle management courses in 2014. Michael's conceptual framework consists of 3 basic components: the physical space, connection layer, and the virtual space. However, while his framework is suitable for some applications, like this framework is widely used in the manufacturing industry for real-time decision-making. However, it has limitations when it comes to open and use-oriented broader applications such as agriculture, well-being, and healthcare or medical. This is where the second type of AIDT framework comes in, the Cloud Cyber Physical System, the C2PS-based AIDT. In this framework, every physical object is automatically accompanied by a representative digital twin hosted in the cloud. And take a look at this more detailed structure graph. This framework consists of the system usage, system administration, and intelligence service layer, peer-to-peer relation layer, and cyber things layer, and final is physical things layer. This framework allows for a one-to-one connection between physical and cyber things, where every physical things and this corresponding cyber things manage a data store. However, while this framework is highly efficient, it can be limited by privacy concerns and requires strong network connection. The third type of AIDT framework is the intelligent DT. This framework utilizes AI inference engines and data mining technologies to capture qualitative and quantitative information in real time, making it suitable for applications such as healthcare, where the ability to forecast and make real decisions is crucial. And here is more detailed about the intelligent DT. Is first to ensure the data privacy and security. A lot of artificial intelligence and machine learning is used in this structure to study and predict. The intelligent DT is highly adaptable and can learn from a physical object over time, making it an attractive option for many applications. And finally, we have the Industry 4 AIDT framework, which is a hybrid cloud CPS and AIDT architecture. This framework is focused on advancing smart manufacturing and consists of a communication model including sensing and actuating intelligence and the representation of the twins connection through a tactile internet. It is highly adaptable and can be used across a range of industries, but it can be complex to implementation. Each of these frameworks has its advantage and disadvantage. The three-dimensional DT framework is simple to understand and implement, but it has limitations when it comes to handling open and use-oriented broader applications. And the cloud CPA-based DT framework is still for handling big data, but may pose the security risk due to the network connection. And the intelligent DT framework is more suitable for well-being and the healthcare application, but may require complicated AI system. The Industry 4 DT framework provides similar features to the intelligent DT framework, but its implementation may require a combination of cloud CPS and AI DT architectures. So that's a brief overview of the 4 types of digital twin frameworks that has been proposed in recent years. As we move forward, we can expect to see even more innovations and advances in this field. And it will be exciting to see how AIDT technology continues to transform various industries. Now that we understand the frameworks for digital twin, let's talk about the life cycle. There are 2 possible life cycles for a digital twin depending on whether the object that needs to be tuned already exists or not. This example of AIDT life cycle comes from the paper by Barricelli in 2019. Let's into the first life cycle. The design process creates both the object and this digital twin, which begin its life as a prototype. During the design phase, the prototype digital twin is used to simulate, test, and validate design choice, utilizing historical data and static data, as well as the result of simulations and prediction. Once the design of prototype digital twin is complete, the process moves to development phase, where it evolves into development DT object that interact with production machine to optimize the assembly of the physical object. When the physical object is built, the development DT object becomes a product DT object and enter the operational phase. During this operational phase, the product DT object mirrors the physical object and continues to learn and adapt by AI or machine learning. Eventually, the physical object may become obsolete or otherwise be discontinued, and the dismissal phase begins. The product DT object is historical data is backed up and made available for future use, allowing designer and domain experts to optimize the production of the future device. And in the second life cycle, the object already exists but does not have connected digital twin. The design phase focuses on the developing a prototype digital twin, while the development phase involves developing the connections between the physical object and the digital twin. The operational phase involves the concurrent use of the both physical object and this digital twin, which are eventually dismissed when the life cycle comes to the end. Overall, the life cycle of digital twin is a continuous process where each stage builds on the previous one, allowing for monitoring, predicting, and optimizing the function of the physical object. As we can see, the concept of the AI digital twin is becoming increasingly important in various industries. It allows for deeper understanding of physical systems, providing insight and opportunities for optimization and improvement. In this video, we have discussed 2 important aspects of digital twin: the frameworks that provide a structure for these implementations and the life cycles that described this creation and maintenance. We have seen that there are several types of frameworks available. By creating an AIDT, companies can gain a competitive advantage. And finally, in conclusion, the digital twin is a powerful tool that can help business to optimize the physical system and improve the operations. It's important to companies should carefully consider the goals and needs when implementing a digital twin and choose a framework that best suits their specific requirements. With careful planning and execution, AIDT can prove significant value and benefit for many years to come. And thank you for taking the time to watch our video on AIDT structure and life cycle. We hope you found this informative and helpful in understanding the potential of the technology. If you are interested in more content like this, please subscribe to our channel for updates on new videos. Additionally, we encourage you to join our community to stay up to date on the latest developments in the AIDT. Thank you again for watching, and we look forward to seeing you in the next video.